Have you ever wondered how the stars and the moons are created? How the sun was created? Or how the Earth and other planets was created? There are many theories and ancient legends on how these celestial bodies were created, but science will tell you this. Solar nebular theory, or the Nebular Hypothesis. This is the most famous and most accepted theory as of to this date on how these celestial bodies, our solar system, the sun, the moon, and also other stars were created. Okay, so these are the things that we're going to talk about today. The learning objectives is, our main objective first, number one, is the formation of the planets. So this would be divided into stages because it literally took 4.567 billion years before this planet was created, this planet Earth only. The stage 1 will be nebula, first stage. Stage 2 is the accretion disks. Stage 3 is the formation of the sun. And stage 4, finally, is the formation of the planets. How did the solar system form and end up with all of these different types of objects? Why is the asteroid belt in between Mars and Jupiter? Why is there another asteroid belt which is called Kuiper belt outside of Neptune? The Oort cloud. Why are the outer planets larger than the inner planets? Why are they more gaseous? And why are the inner planets more terrestrial? Why is the sun so big? Why is the sun made up of hydrogens and heliums? So we're all gonna talk about it in this lesson. Stage 1 is the nebula. It's just like a cloud of gas and dust. According to the solar nebular theory, the sun and the planets of our solar system formed about 4.6 billion years ago from the collapse of a giant cloud of gas and dust called nebula. A nebula is mostly made up of hydrogen and helium and other ionized gases. Stage 2 is the accretion disk. The process occurred with the nebular collapse. When the temperatures continued to increase, the solar nebula spun faster and faster, and the solar nebula flattened into a disk. Have you ever wondered why the orbits of the planets is in a flat disk? It is because of this stage. The temperature continued to increase. Why did the temperature increase? When the nebula flattened into a disk, it became more compressed. And here on Earth, when things became compressed, when they have higher pressures, the temperature also increases. That is the same with that property is also the same in space. When the clouds of gas and dust flattened, they became more hotter, and the solar nebula spun faster and faster. Here is the protostar, the sun to be collected, most of the mass in the nebula center. So this is a more creative representation of that. When the gravity grew stronger, so why did the gravity grow stronger? Again, because when there is more mass, there would be more gravity, and this would attract more matter, more dust, more particles. It would attract more objects eventually. So this is a more creative representation of that. The sun to be, or it's like a fetus star in layman's term. It's a fetus star, but in a more proper way, it is called a protostar. Stage 3, which is the formation of the sun. So when the protostar became existent, when more matter collapsed in the center of the disk, it will most likely form in the center because it is where it could get more matter, and it could collect or attract many clouds of dust and gas from the nebula. Okay, so this is a more creative representation of that. This is the stage 3, formation of the sun. The matter continued to collect as the growing force of gravity drew it towards the center. So that's what I'm talking about earlier, that when the gravity grew strong enough, it would create this ball of gas. Yan. Eventually, the gas warmed from the increasing pressure. As the mass further increased, the gravity also increased. As a result, the temperature continued to rise. It is called the protostar. Why is it called the protostar and not a star? A protostar is an object in which no nuclear fusion has occurred, unlike a star that is undergoing a nuclear fusion. A protostar becomes a star when nuclear fusion begins. So that is the main difference of a protostar and a star. So there is a nuclear fusion. What is nuclear fusion? Nuclear fusion is when hydrogen, in this case, because if you would remember earlier, the clouds of gas and dust is made up of hydrogen, helium, and other ionized gases. When hydrogen is subjected to intense heat and pressure, these two hydrogen atoms will combine and will create a helium atom. In the same way, other helium atoms in the center of the sun would also combine under intense heat and pressure, and it would continue until it create other elements in the periodic table. That is the nuclear fusion. In the protostar, no nuclear fusion no nuclear fusion is occurring. So that means the gravity, the pressure, and the heat, the temperature is not enough for hydrogen to combine into helium. Stage 4 is the formation of the planets. Inner planets, due to their higher boiling points, only metals and silicates could exist in solid form closer to the sun, and these would eventually form the terrestrial planets of Mercury, Venus, Earth, and Mars. The inner planets is small and terrestrial because the sun have collected those other gases. So the outer planets, the giant planets, Jupiter, Saturn, Uranus, and Neptune, formed beyond the point between the orbits of Mars and Jupiter, where material is cool enough for volatile icy compounds to remain solid. So this is the reason why the outer planets are big and gaseous, because in this part of the solar system, the sun could not absorb these large masses of gases. So aside from these inner and outer planets, there are also dwarf planets like the Ceres, Pluto, which was a former planet. We also have the leftover debris. So some asteroids and dusts will not become a planet. Instead, they will form the asteroid belt, Kuiper belt, and the Oort cloud. The asteroid belt is located in between the orbits of Mars and Jupiter. A more creative representation of that. Okay. There. That is the formation of the planets. The inner planets. This is the Mercury, and then the Venus, the Earth, and the Mars. This is the colder or outer regions. Yeah. Temperature dropped, water vapor condensed and turned to ice. When the accretion of most ice and gas were complete, we were left with gas giants, Jupiter, Saturn. This is Uranus and Neptune at the very ends of the solar system. Okay, to summarize, the solar nebular hypothesis describes the formation of the solar system from a nebula cloud made up of collection of dust and gases. It is believed that the sun, planets, moons, and asteroids were formed around the same time, around 4.5 billion years ago, from a nebula. So, thank you everyone, and if you would like to see the references for this video, you would find it are down below. This is my cousin and my sibling. They're my brother. They are the ones who helped me with my presentation and setting all this up.